Hello everyone, and today we are going to study the suboccipital triangle. The suboccipital triangle is situated behind the nape of the neck, that is in the craniovertebral junction, that is between the occipital bone and the posterior arch of the atlas and the vertebral arch of the axis. So there are two suboccipital triangles, one on each side, and to dissect them we have to start from the external occipital protuberance, give a vertical incision along the ligamentum nuchae to the spine of the seventh cervical vertebra, and then give horizontal incisions at its upper and lower end to create a rectangular window somewhat like this. And when you have separated the skin, the superficial fascia and the deep fascia, and you reach the muscular plane, you can see this giant muscle, the trapezius. Actually the trapezius is trapezoid only when you take the both trapezius muscles of both sides. The single muscle is a huge triangle which covers the muscles of the back, and you can make out the attachment of the trapezius, its origin from the external occipital protuberance, superior nuchal line, ligamentum nuchae, spines of the cervical and thoracic vertebra, and the muscle converges towards the shoulder, and it is inserted into the spine of the scapula, the acromial process of the scapula, and the lateral one-third of the clavicle. And just beside the external occipital protuberance, you can make out that it is pierced by the occipital artery and vein and the greater occipital nerve, which is one of the cutaneous nerves of the scalp. And from the external occipital protuberance, if you go along the superior nuchal line right up to the mastoid process, you can understand that here you will have the attachment of the trapezius, further laterally sternocleidomastoid, below that splenius capitis, and below that longissimus capitis. So you have trapezius here, you have the sternocleidomastoid here, underneath you have splenius capitis, and still below and out on the mastoid process longissimus capitis. So the first step is to cut out the trapezius, fold it down, and you can leave the sternocleidomastoid and the longissimus capitis intact because they are outside the required field. And when you have removed the trapezius, underneath you will find this splenius capitis. This is a splint-like oblique muscle going to the superior nuchal line and the mastoid process from the spines, lower cervical and upper thoracic spines. So first you have to cut out the trapezius, then you have to cut out the splenius capitis, then you will reach another giant muscle, the semispinalis capitis, this one. So here you have already cut out the trapezius and the splenius capitis, and you have reached the underlying semispinalis capitis. Let us look at it here. See, you have cut out the trapezius and you have cut out the splenius capitis, and you have reached the semispinalis capitis, another very big muscle. And again you have to cut out the semispinalis capitis as well, and only then you have reached this point, the unveiling of the suboccipital triangle. And you can see that this triangle is bounded above and laterally by the obliquus capitis superior, above and medially by the rectus capitis posterior major, and below by the obliquus capitis inferior. In addition, you have this muscle, rectus capitis posterior minor. Now rectus capitis posterior minor from the posterior tubercle of the atlas to the occipital bone below the inferior nuchal line, rectus capitis posterior major from spine of the axis to occipital bone below inferior nuchal line, obliquus capitis inferior from the spine of the axis to the transverse process of the atlas, obliquus capitis superior from the transverse process of the atlas to the occipital bone between the superior and inferior nuchal lines. So from your knowledge of osteology, you already know that on the occipital bone, on the squamous part of the occipital bone, on its posterior surface, between the superior and inferior nuchal lines, you have semispinalis capitis and superior oblique, and below the inferior nuchal line you have rectus capitis posterior minor, rectus capitis posterior major, and you have uncovered the suboccipital triangle. In the floor of the suboccipital triangle you have this, the posterior arch of the atlas as well as the posterior atlanto-occipital membrane. We actually call them obliquus capitis superior and inferior, and not just superior and inferior oblique, to distinguish them from the superior and inferior oblique muscles of the eyeball. Now if you look at this diagram of the occipital bone from osteology, again you can recap that at the superior nuchal line medially you have trapezius, laterally sternocleidomastoid, splenius capitis, and still outside and below longissimus capitis. Between superior and inferior nuchal lines, medially semispinalis capitis, laterally superior oblique, below inferior nuchal line, medially rectus capitis posterior minor, laterally rectus capitis posterior major. And now if we look at the next diagram, so here you can see the suboccipital triangles of both sides, and here is the floor, the posterior arch of the atlas, groove for the vertebral artery, and posterior atlanto-occipital membrane going from the posterior arch of the atlas to the posterior margin of the foramen magnum. And again you can see the muscles in the boundary: rectus capitis posterior minor major, superior oblique, inferior oblique, semispinalis capitis, splenius capitis. And you can make out this third part of the vertebral artery. It has come out of the foramen transversarium from the transverse process of the atlas. It lies on the groove for vertebral artery over the posterior arch and goes deep to the posterior atlanto-occipital membrane through this opening, and it goes in front of the brain stem, and it goes in front of the medulla oblongata right up to the front of the pons. And so here you can have a very good idea of the suboccipital triangles of the two sides. Now, apart from the third part of the vertebral artery, another content of the suboccipital triangle is the dorsal ramus of the first cervical nerve, also called the suboccipital nerve. Now, this suboccipital nerve supplies the muscles forming the boundaries of the suboccipital triangle. That is, it supplies rectus capitis posterior major minor, superior oblique, inferior oblique, as well as semispinalis capitis. Occasionally it gives a cutaneous branch to this region on the back of the scalp. So the third part of vertebral artery, suboccipital nerves, they are all contents of the suboccipital triangle, as well as this huge suboccipital venous plexus. This suboccipital venous plexus obscures almost all other contents, and it connects the vertebral veins, it connects the occipital veins, it connects the deep cervical veins, and it's a big mass of veins. And if you don't clear up these veins, then you cannot get this picture and you cannot see this. Apart from this, if you go below the obliquus capitis inferior, you can see this very thick nerve. This is the dorsal ramus of the second cervical nerve, dorsal ramus of C2. This is called the greater occipital nerve. It hooks around the inferior oblique and pierces the trapezius and semispinalis capitis and becomes cutaneous over the vault of the skull. It is one of the cutaneous nerves, very important cutaneous nerves of the scalp. And still below that, here you can see the third occipital nerve, which is again the dorsal ramus of C3 or third cervical vertebra. So dorsal ramus of C1 is the suboccipital nerve, dorsal ramus of C2 is the greater occipital nerve, dorsal ramus of C3 is the third occipital nerve. These are also structures that you will come across in the dissection of the suboccipital triangle. And here you can see those nerves displayed to better effect. You can see the suboccipital nerve, greater occipital, dorsal ramus of C2, third occipital, dorsal ramus of C3, and you can see the third part of the vertebral artery as well. Now what you can make out is that the dorsal rami of C1, C2 and C3 do communicate with each other, and this communicating mass is also known as the posterior cervical plexus, just as you have the anterior cervical plexus. I think I have taken up much of your time already. Thank you.